Hello everyone, today let's take a look at QP number 35, another combinatorics question. We have a deck of cards that's shuffled and the cards are dealt one by one until a 7 appears, so it's asking us to find the probability that exactly one king, one queen, and one jack appear before the 7 appears. So we're dealing cards until the first 7 appears, so for instance, say I deal out a 2, and then maybe a 5, and then maybe I get a jack, and then maybe I get a 7. Well, this is kind of our ending point. Now notice that here I did not get exactly one king, one queen, and one jack before my first 7, so this would not satisfy our condition, the specific combo right here. So this right here would be an example of something that would satisfy our condition. You can see we dealt exactly one jack, one king, and one queen before getting our first 7. But now say for instance I had another jack here instead of this 9, well then this combination would not satisfy our condition because we want exactly one king, one queen, and one jack, and here we have 2 jacks before our first 7. So now how do we actually solve this? Well, the first thing to note is that we don't care about any other cards other than our jacks, our kings, our queens, and our 7s. And that's just because this question's only asking about the relative ordering of the king, queen, jack, and 7. For instance, this ordering right here would still be invalid if I removed all 4 of these filler cards, and if I inserted, let's say, a 10, a 9, whatever in here, it's still going to be invalid, right? We only care about the relative ordering of these 4 different types of cards. So given that that's true, we can basically reduce our deck size to 16 different cards, where I have the King of Hearts, Spades, Clubs, and Diamonds, and then the Queen of Hearts, Spades, Clubs, and Diamonds, and etc., all the jacks and all the 7s. So now that I've reduced my deck to 16 cards, let's calculate the probability now. Well, first we need to calculate the total. The total number of ways to permute 16 cards is 16 factorial. So now that we've done that, let's calculate the number of outcomes in our restricted space where the 7 has to come after our jack, queen, and king. So how do we do this? Well, I've drawn out our 16 bars for the 16 places in our deck, and just note that the first 3 have to be occupied by one king, one queen, and one jack exactly, and then the 4th one has to be a 7. So how many combos of that are there? First of all, here I've drawn out the remainder of our 16 bars. So now essentially what we're going to need is obviously a 7 of any type, and then some type of king, queen, jack here. So I have 4 kings, I have 4 queens, and I have 4 jacks. So there's going to be 4 to the 3rd different ways to have a king, a queen, and a jack. And now I can permute these in any order. I can have jack, queen, king, king, queen, jack, queen, king, jack, right? I have 3 factorial ways to permute 3 items, so I also have to multiply by that. And now 7 has to be in position 4. There are 4 7s, so now I multiply by 4. And now for every single combination of these 4 cards, we're going to have 12 cards remaining. So that's going to be 12 factorial ways to permute those. So these are our total number of restricted outcomes. And now let's take that over our total outcomes. So this is going to end up being our final answer. Let's do a little simplification. So we can expand it out like this. We know that 4 squared is 16. So we can make this 4 squared, cancel out this 16. So this is going to be our final answer. When we fully work this out, we're going to get something around 0.035, so about a 3.5% chance. So this right here is our final answer, however you want to write it. Now maybe just one more way to think about it that might be a little easier. Well, we have 16 cards, and we know that if we get one of these for our first card, then we still have a chance of having a valid combination. But if we get one of these, then we don't. So we have a 12 out of 16 chance here. So we've placed one of our cards in the first position. Let's just say it was the King of Diamonds, but it could have been any of these 12 right here. Well, now we know that for our second card, obviously it can't be the King of Diamonds, but it can also be any of these kings, so we can eliminate them. And any 7 would also make it invalid. So we have 8 different choices out of how many? Well, we placed 1, so we have 15 cards left. So we're going to have an 8 out of 15 chance of keeping a valid solution alive. Now for our third card, well, we've placed another card here. Let's just say it was the Queen of Hearts. Again, it doesn't matter. Well, now these are all going to be invalid, and the only hope of keeping a valid solution alive is going to be a jack. So we have 4 jacks, and there are 14 cards left, so this is going to be a 4 out of 14 chance. And now we've placed one of our jacks. Let's just say it was this one. And now for our final card, we know that it has to be a 7, has to be one of these. There are 4 7s, and there are 13 remaining cards. So we also have a 4 out of 13 chance here. So now if we multiply all of these together, notice that this is exactly the same as this, right? These are both valid solutions here, just different approaches.